And here we go. We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Following up.
Water towers fly! Yes!
Tango down to nominal.
Flight downside SPD off. Bring in SPD off. Off. It's orange!
Oh my god! Oh my god!
Decollage.
Look at this!
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting with the flare, correct?
Yikes. You bet. We don't need any more of these.
Hello and welcome to Launch Complex 39A at Kennedy Space Center in Florida, where SpaceX is getting ready to launch NASA's IMAP mission to study the sun. This is going to be an exciting mission. It's going to be a beautiful launch this morning. I'm Jack Beyer. I'll be your host for today's launch. We are NSF, NASASpaceflight.com, and joining me is Alex on commentary. Alex, how are you doing, buddy?
I'm doing fantastic, and it is quite an interesting mission today. We'll talk all about it as much as we can because it's not a Starlink, it's not geocommunications satellite number 45 of the year, right?
Right.
It's a rather interesting mission. Missions, actually, plural.
It's time to do some science. I hope you're ready on this early morning launch to do some science, or to watch a satellite launch that's going to do science. So this will be an interesting one to talk about. If you have any questions about today's mission or anything in general, life, what does it all mean? Why is it for? You can at NASA Spaceflight or at NSF in chat, and we'll see your questions pop up in some software we have running in the background. Also, joining us out in the field, we have none other than the legend himself, Max Evans. Max, how do we have you?
Good morning, everybody. And Jack, that was way too kind of an intro. But good morning, everybody. It is a fabulous morning, I have to say. The weather is nice and calm. Sun should be coming up here in just about 30 minutes or so. And we are getting all set to watch a Falcon 9 get off the ground from LC 39A. So it's always a treat.
Indeed. Look at that beautiful sunrise lighting. 46 minutes to go. Also, we have Jay operating today's stream, and I think we have Gage helping out in the background, and looks like Kevin is maybe also around. Hi, Kevin, maybe. But yeah, let's get right into it. Alex, what's going on with this mission? We're studying the sun again? How many probes do we need to study the sun?
Yeah. There's actually 3 here. They study the sun in different ways. So, of course, the primary payload for this mission is NASA's IMAP spacecraft. IMAP stands for Interstellar Mapping and Acceleration Probe, and it's going to study not the sun itself, but how it interacts with its surroundings, what it's called the interstellar medium out there within the galaxy, essentially. And so that interaction, that sort of back and forth between what the sun does and what the interstellar medium does. It happens on the heliosphere, in the heliopause of the heliosphere. The heliosphere being this sort of magnetic field around the sun and whatnot, and the heliopause is that sort of inner portion of that heliosphere where that happens, and it's gonna be, as its name implies, mapping all of that, and also
Hang on, Alex. I need to heliopause you for a second really quick.
Okay.
To thank Mats for gifting 50 Red Team memberships. Holy cow. Thank you, Mats. That is outstanding. I don't even know what to say. I saw that come through, and I had to bring it up. Also, it allowed me to say I need to heliopause you. Please continue. Thank you, Mats.
Yeah, I was in a role here. So yeah, it's going to be looking at the heliosphere itself. It's going to be going out instead of in, right? And that is a very important thing again because it's part of how the sun interacts with the surroundings of the solar system. Now, the other two payloads, so that is from NASA, right? There's another NASA payload as well, which is called the Carruthers Geocoronal Observatory, or also GLIDE, because it's got like another name, of course. And that one is it's gonna look in at Earth instead. So it's gonna look at Earth and the interaction between the Earth's exosphere, the outer layer of the atmosphere, with the sun's solar wind and other sort of interactions as well with all of the things that are going on in the solar system as well. So that is sort of the other side of what you can look at this at what the sun does, right? One is out at the heliosphere and all that. Another one is to Earth itself. And the third one is the other payload going on this on this mission, which is for NOAA. It's the Space Weather Follow-on Lagrange 1 satellite, and it is directly imaging the sun itself, and also sort of trying to get a little bit of information about things like coronal mass ejections and whatnot. So you have 3 different spacecraft looking at different locations in space. And all of them are all about what the sun does. They are heliophysics experiments and
SMA.
probes and whatnot.
SMA is go.
We've got some
SMD.
mission control.
This is SMD. IMAP is go.
NASA MIM.
NASA MIM is go.
LSP.
LSP is go.
NASA team is ready for propellant load and launch.
Nice.
We got a go, no go.
Yeah, that's from NASA itself. I'm
Great.
assuming. Yeah, I'm assuming SpaceX Launch Control is doing their own as well. So yeah,
Yeah.
those are the 3 payloads riding on today's mission, all about the sun.
Awesome. Always love to see more science missions get launched. Definitely want to know better how the sun interacts with our atmosphere at the very least, because hey, we're launching a whole bunch of satellites, and knowing the space weather environment's important. So study the sun, study the sun's interaction with the Earth's magnetosphere. Makes sense. Neat. Max, can we get a situation report down there? What is your status this morning? How's the conditions looking, and we doing anything fun or special?
The vibes this morning, if I may say that, are feeling pretty good. There was a bit of concern yesterday, especially after we had that delay, which NASA was able to confirm for us, was that just the teams at play with SpaceX and just needed some more time for the recovery vessels to get into position for launch, which is now this morning. But we are feeling good today. We were out at the pad earlier to put cameras around the launch pad. Everything was looking good there, minus some rain that was in the area. But speaking of weather, Jay, if we could pull up the forecast when you have a moment. The forecast from the 45th Weather Squadron, based at the Patrick Space Force Base, is only forecasting a 10% probability of weather violation this morning, which is really, really, really good. And so the only real concern they have is the cumulus cloud rule, but any other chances of precipitation or thicker clouds come into play as the day goes on and the temperatures around the area begin to increase. But for the time being, everything is looking good weather-wise. And obviously, NASA teams just pulled go for propellant load, at least on their side. And we should be getting a word here from SpaceX soon as well, maybe. It's nice to have comms from them, I have to say. But we are feeling good. And if I may say so at this point, myself and Mr. Jerry Pike are stationed off-site at a very particular location to get hopefully a live shot of Falcon 9 and IMAP and the other payloads transiting the solar disk of the sun at around 20 seconds after liftoff. We've been trying to organize a shot like this for the stream for a while, and I guess everything just came together, and with how beautiful this morning is and how just everyone's schedule is lined up. So we are looking and feeling good over here, and hopefully that continues as things hopefully trend in the right direction as the countdown continues.
Awesome. That is super
This
exciting.
is the launch director on the countdown net. The propellant load and launch go, no-go poll is complete, and we are go for propellant loading and launch.
Right on cue.
Yeah.
Isn't that slightly curious how we got the NASA go, no go, then like 2 minutes of silence, and then the LD saying their polls go? Like, come on. I know it's like an automated thing on a computer, probably. There's not like a bunch, like, just have someone look at the computer readout and say go each time a subsystem is go. I like getting those every time we do. I'm glad we got one today. Really quick, let me thank some people. 38 minutes to go. Tom Brown becoming a Capcom member. We have the membership program. If you don't know about it, it exists. It's part of our YouTube channel. You can sign up and support us at various levels and get a whole bunch of different perks and extra content. At Capcom level and above, you do get access to our members-only Discord, which is a really great place to hang out and talk about rockets or food or gaming or whatever you want to talk about. It's a really cool place. So thank you for that. We really can't do what we do without the membership program. Likewise, Bo'Neill, 123, becoming a Red Team member. Crisp Bag Boy becoming a Padrat member. Mick202 becoming a Padrat member. Chris P becoming a Red Team member. Line becoming a Padrat member. And yeah, there's Matt's once again with the 50 gifted Red Team memberships. With all the Starship testing, we did members multi-view. That's another perk that you can get. So if you got a gifted membership, I think you should be able to go back and like see the multi-view if you want to go back and look at testing and see what that's like, see what sort of content you have access to now. So there you go. Thank you, Mats. Thank you to everybody for the support. Coming out on an early morning launch. This is a fun one, though. This is not your ordinary Starlink. In fact, it's not a Starlink, and it's not a ComSat. And it's not an Earth observation set. Well, I mean, it kind of is, but it's not like a Planet Labs or a SpySat. This is science. It's a science mission. And to that end, Alex, where is this mission going? It's not going to low Earth orbit, is it?
Yeah, no, it's actually going far out there. Nice. And
this is the launch director with abort instructions.
There.
For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
All right, cool. More LD comms with abort instructions. Anyways, Alex, please continue.
Yeah, these are the standard, sort of things that they need to say in order to get ready for propellant load. So yeah, this mission is gonna be consisting of essentially a very, very interesting profile where we're gonna get the 3 payloads out to the Earth. To the Sun-Earth Lagrange point 1. So there are these different points, right, in that gravitational interaction between the Sun and the Earth, where you've got 5 different stability points, right, where sort of it cancels out-ish, if you will. And so if you put something in those points, then it's going to be very stable and very fine there. And so this one is going to the L1. As you can see there, there's the L1 in front of the...
I like how it says not to scale.
Yeah,
if that wasn't clear, this is not to scale. It's pretty clear, but just in case it wasn't.
So the L1 and L2 positions are sort of aligned with the Earth and the Sun, and also the L3, I guess. L3 is all the way at the other end of the Sun, and then you've got L2 on the back of the Earth, and in between the Sun of the Earth and the Earth, you've got... There we go. That's propellant load has started.
Yay.
And then in between the Earth and the Sun, you've got L1. That is where these 3 payloads are going. It's about 1 million miles away, roughly 1.5 million kilometers away. So yeah, it is right there, it is a very nice place to put something that, you want to look at the sun or you want to look at Earth. These three are going to be doing that. So there you go.
Which one is James Webb at? L2?
L2, yeah, on the other side.
It's like shielded from the heat of the sun by also the Earth.
Yep, you are
Neat.
correct.
Super cool. I always thought the Lagrange points are just like fascinating. It's one of those quirks of orbital mechanics that exists that once you learn about, I don't know, it's always fascinating to me. It's neat that this is going to L1 today. I don't think of all the launches that I've commentated or seen, I can't remember one that went to L1. It's always like, oh, this is low Earth orbit, or oh, this is geosynchronous, or oh, this is sun synchronous, or maybe this one's slightly retrograde. No, this one it's a fun launch. This is going to be really a treat. Max, I did see some people in chat asking earlier, like Xyanox 07, jellyfish is impossible, right? It's the sun has risen too far.
Yeah, at that point, the sun would have been up for about 18 minutes at this current T0. So unfortunately, when the sun is up, the possibility of a jellyfish goes away completely. But do not fret. We have plenty of launches coming up in the early morning hours. In 2 more tomorrow morning, albeit probably not going to have a jelly with those either. But they're still going to be rather pretty ones. But for this one this morning, no, I don't think so. But there should still be some really cool opportunities to see there's a point in flight where Falcon 9 reaches a certain altitude, and it creates some condensation clouds up in the cons, as we say, and that casts a very long shadow. So there are a lot of good chances for some visual eye candy this morning, but unfortunately a jellyfish is not going to be one of them.
Still going to be an absolutely gorgeous launch with the possibility of that transit. Alex, are we seeing frost? Is it happening? Is it happening? Dot GIF?
Yeah, it is right there.
Ron Paul and the lasers. What does that mean? Why is that good? Oh my God, Max. I'm trying to stay on the rails here. We're doing science. Alex, why frost good?
Well, because that means they are loading propellant. As we heard over the countdown, it's a rare thing when we get the countdown feeds from SpaceX or NASA. So this is a very neat trick. But yeah, we are always relying on the frost. Now it's more like, yeah, we heard already. They're loading propellant load. We know. So the frost is sort of like secondary now. But yeah, every other mission, it's like, oh, we got to look for frost, because otherwise we're not sure if they are going into propellant load and whatnot. Here it's more like, yeah, we know.
Yeah, and thanks to this being a NASA mission, we have been getting those comms, and it's always a treat when we do. 31 minutes to go. Propellant loading onto Falcon 9. So this booster is booster 1096-2, which means it's only flown once so far. What did it fly on previously, Alex?
It launched on the Kuiper Falcon 1 mission, the first launch of Kuiper satellites on Falcon 9 about 70 days ago.
Nice. And it's going to land on a drone ship. Just read the instructions, correct?
Yeah, it's going to be landing offshore. It's going to head, so the launch profile is just going to be, Falcon 9 lifts off, it heads to the east, then the booster will separate about 2.5 minutes into flight, and then it'll return to a landing on just read the instructions. The second stage will continue into orbit. It'll shut down around 8 minutes into flight. That is when it is expected to put the 3 payloads into a parking orbit. And then there will be another burn around an hour later, roughly T plus 1 hour and 12 minutes. And that one will push the 3 payloads out to that sort of transfer orbit that will get them to Lagrange point 1. So that is more or less the profile for today's mission. And, roughly the last of the spacecraft should be the Carruthers Corona Observatory deployment, and that'll be at 1 hour and 36 minutes. So about 96 minutes after liftoff, everything should already be on their way out to deep space.
Deep space. That's so cool. It's so much cooler than low Earth orbit.
Literally.
I'm hyped. Yeah, literally, it's like a colder. It's like actually colder. Nice, Max. More questions. Let's do some questions. Astrophysics is asking, doesn't L1 require Falcon Heavy?
Nope.
Is this a launch that's possible because they've been getting more and more performance out of Falcon 9, or it's just a light enough payload in this case?
Yeah, it's a rather light payload. All three payloads combined add up to roughly 1,500 kilograms, so it's not really that much. And it is not even Falcon 9's first time that it's launching something to the Sun-Earth Lagrange point 1. One of the first few payloads for NASA. Oh, excuse me, a bird just almost startled me. Yeah,
I think
things
it
that
did. I
happen.
think it did startle you, my guy. Just gonna let you know. I think it actually.
They
did
like
start.
to really come through my window. Sorry. Anyways,
I have so many questions, but I'll save them for later.
one of the very first missions that SpaceX launched for NASA and NOAA was the Deep Space Climate Observatory, or DISCOVER, and that was actually launched to the Sun-Earth Lagrange point 1. That was all the way back in 2015, and I'm gonna spoil a little bit of probably some of the explanations for later, but one of these payloads is actually going to be replacing that same satellite that Falcon 9 launched all the way in 2015. So really, really interesting stuff.
I'm still stuck on the birds just come in your window.
Yeah, it's a thing. I mean, I live in a block of apartments and whatnot, and so they like to nest around my window and whatnot, and sometimes they get confused and fly through my window. But yeah,
Good deal. Turtle Sanctuary, thanks for the super. They say, is Max covering IMAP because Mr. Maps isn't good enough as Max is to cover IMAP, or is Mr. Maps waiting to jump on late like Stream was of no fault of Max's? Turtle Sanctuary is like trying to write riddles for me to read early in the morning. My head hurts. Thank you, Turtle Sanctuary. Also, thank you to Astro Knucklehead. What's up, buddy? Still out there on the Space Coast. Gonna get to see another launch this morning. They say, hey, Jack, at KSC Banana River viewing bleachers for an in-person launch number 2. 4 more here, and then Flight 11. Living the Space Nerd Dream. That's awesome. Get it, buddy. And Fawad asking with a super chat. Thank you so much. Jack/Alex, inform please if Falcon is going to put it in geostationary transfer orbit and then
No.
satellite would raise itself. No. You said there is a brief parking orbit for like an hour.
yeah.
But that's not a geo parking orbit.
No, it's just low Earth orbit, usual, standard low Earth orbit, and then it'll fire all the way. It's not going to be a geostationary transfer orbit or anything like that. It's going to be much more energetic. It's going to go all the way out. Then the satellites, of course, they need to do a little bit of a burn to be able to, not keep going and actually enter orbit around that point. But that'll be, their thing, and that happens with pretty much every mission that goes to one of these Lagrange points. Like, it's not something because Falcon 9 cannot do that. It's just, well, I mean, it's not like you can carry the second stage all the way out there. It's gonna take like 108 days to get to that Lagrange point. So yeah.
Keep talking. I'm doing a thing.
Okay. I don't know what to say. I already said everything.
All right, here we go. Terrence Thew is asking, staying on International Drive, do you think I'll see the launch? Max, it's tough to see a launch from Orlando or Tampa during the day, but it is possible. What do you think?
It is possible, and as at least the Mark 1 eyeballs are showing me, there is plenty of clear skies around. So as long as you have a good angle and the sun isn't directly in your face, you should at least see it in the sky. So a lot easier to see at night because obviously the exhaust contrasts against the dark sky really well. Not so much during the day, but if you keep your eyes peeled out to the east, you should still see it though. Yes, you might even hear it too if you're in a quiet enough area too.
So not International Drive.
Well, you'll
For
see
hearing
it there,
for
but
hearing it.
yeah.
Right.
You'll see it from there if you have clear skies, but probably not going to hear it.
Got it. Yeah, I mean, it is. It's pretty neat to be able to just like step outside or look over whenever you're somewhere in Florida with visibility and just see a rocket ascending into the air. Like it's one thing to go to a rocket launch with the express point of seeing it. It's another thing to just like, oh, is that the control room for?
That's
for the
for
Carruthers?
the yeah.
Neat. I like the blue lights. It's got some ambiance. But yeah, I think I forget. It might have been 135. I think it was the last shuttle launch. I was working on a stupid reality TV show in the Orlando area, and I told the whole crew that day, like in the morning, I was like, "Hey, this thing's happening. We should like take a minute or two, or maybe include it in what we're shooting if the producers think that's okay." And sure enough, like we just all stopped and looked over and was like, "Yep, that's the space shuttle. Cool. All right, back to work." There's something different. There's something different about that, It's like more routine. It's like when you're going out for some coffee and you see a plane, on final approach coming into land. It's more like that, and it's really neat. So that's exciting, Terrence. I hope you get to see it from International Drive. Everyday001 is asking, what are the 4 things sticking out at the bottom of the fairing? We're getting these fiber feeds from NASA. Intermittently, we'll get those like really close-up cameras and shots of the fairing. Hard to say without looking at it right now, but probably the little venti things, right, Alex? The fairing has like little vent covers that get pulled off as the rocket launches, right?
Yeah, because obviously right now it is it's actually a bit of a higher pressure than Earth's atmosphere, so that the air sort of escapes out instead of coming in from the atmosphere and keep a clean environment for the 3 spacecraft. But then as the rocket ascends, it's gonna head into near vacuum conditions in space. You kind of have to vent it out, and so that's what's gonna happen there. It's gonna be doing all of those. Like those vents are precisely to equalize the pressures.
If you've ever seen Breaking Bad, it's like the Fly episode where you want to have positive pressure. Nothing can get in.
Yep.
Yeah, sometimes during launch, we'll, depending on the lighting or the angle of cameras, we'll see some of those vent covers come off, and then I'll see chat. People will be like, "What was that?" And it's like, "No, it's fine. It's fine. Don't worry about it." ResistoJet, kind of on the fairing train as well. They say, "Is this the second flight for the booster?" Yes. The fairings look like they may be new.
They are.
They're quite nice. They're quite pretty.
Serial number 230 and serial number 237, if you're
Nice.
curious.
I am curious. How did you just see that because we had the close-up shots earlier?
Well, they are painted on the fairings at the bottom, and NASA released pictures of the rollout and everything, and integration and all that, so we could see the numbers on
Stage 2, RP1
the fairing
loading
apps.
complete.
There we go. Prepare for the T-minus 20-minute vent. There it is.
Hooray, everything is on track. The T-minus 20-minute vent is doing its T-minus 20-minute thing. Which is what exactly, Alex?
Well, they're chilling down now the lines in preparation for stage 2 liquid oxygen load, which should be happening in about 4 minutes from now.
Sweet. So everything is progressing. Under 20 minutes to go to the launch of IMAP now from LC-39A. I have to keep trying not to say Slick 39A because of that. Because of that thing earlier. It's like it has wormed its way into my brain.
LC-39A.
Yeah, no, that's not. It's
That's
not
so cursed.
It's not Slick 39A. It's LC-39A. It's not Slick 39. Somebody was asking.
Actually,
go ahead.
Actually, Jack, it's not LC-39A. It's historic LC-39A.
The hollowed
HLC.
ground of historic LC. Human launch? Is that why HLC, Alex?
Historic Launch Complex
Oh,
39A.
okay. Yeah, nice. It makes me think like horizontal launch and then I'm thinking of like a Falcon 9 launching horizontally, and it's no, Jack. We're staying on the rails. We're trying to do some science launching today. So let's keep answering your questions. If you have any questions, as a reminder, once again, you can @ NASA Spaceflight in chat, and we'll see your questions pop up. And now you don't have to type out NASA Spaceflight. You can just type @NSF, like Nevada, Sierra, Foxtrot, and that works too. So ask away. Joshua Bully is asking, can you explain the difference between a sun-synchronous orbit and going to a Lagrange point? They seem sun-synchronous. Are the terms interchangeable? No.
Nope.
Please elaborate, Alex.
Yeah,
and enlighten us.
So a sun-synchronous orbit is an orbit around the Earth that essentially is sort of always keeping the same illumination down on the ground. So they are called sun-synchronous because the orbit, because of orbital mechanics, essentially the shape of the Earth, it's a bit sort of bulgy on the equator, right? And the way that the orbit sort of precesses, as it's called, it's essentially sort of rotating instead of being fixed in space. If the Earth was a perfect sphere, it will be fixed, but because it is not, it sort of tugs the orbit a little bit every day. And sun-synchronous orbits are such that the orbit gets tugged about 1 degree east, more or less, every day. And if you count how many days there is in a year, that's 365 days. So roughly 1 degree every day. That means a full circle, which means as the Earth rotates around the sun, that 360-degree angle, right? That means the orbit will always be in the same sort of orientation compared to where the sun is located, because it's rotating almost 1 degree every day, essentially the 360 degrees that the Earth is moving around the sun as well. So that's why it's called sun-synchronous orbit, because it keeps that same sort of constant angle, if you will, of illumination with the sun, with where the sun is located. The Lagrange points, the one that it is being sort of sent these 3 payloads to, it is a sun orbit. It is an orbit around the sun. It is just a very specific, very special point in that orbit around the sun where you can sort of let the satellite stay there, and it's more or less stable because of the interactions. There we go. Because of the interactions between the Earth's gravity and the sun's gravity. It is just a special place, but it is an orbit around the sun. It is not an orbit around the Earth. And it's much, much further away. Sun-synchronous orbits are just types of low Earth orbits, roughly, anywhere between 350 to 600, 700 kilometers in altitude. Lagrange point 1 is a million miles away, roughly 1.5 million kilometers away from Earth. It's really far out there.
So neat. Again, this is not an ordinary, not your ordinary Starlink. It's not a Starlink. It's not a ComSat. It's science, and it's going to L1. So it's kind of a fun and a little bit of a different mission this morning. Good question from Joshua. And thank you, Alex. I somehow knew I could throw an orbital dynamics question at you, and you would be able to have a very good answer. I certainly knew. Like I was like, yeah, no, they're 2 different things. Could I have explained it? Absolutely not.
One day, I wish someone will give me the green light, and we can make a video about different trajectories and orbits that are sort of the usual ones, if you will.
I'm in just so that we can do the unusual ones at the end. Like, here's Alpha's first launch going due west out of Vandenberg. Like, all the weird stuff. Because when you cover all the standard orbits, you also need to cover the irregular ones.
And
go ahead.
I was just gonna add one little thing as well. It also goes along. A lot of people always asked us, like, where is this launch going to? And it matters where it is going to in like the end point of where this is going, right? This mission matters for where you want to throw your rocket in which direction, right? If you're going to sun synchronous, it's going to go one way. If it's going to low Earth orbit, ISS, for example, it's going to be... So this one in particular is going roughly straight east out of the Cape, for example, because of where it's going. Just to put an example of that.
Yeah, I mean, I imagine they want all of the push they can get from the Earth.
Mhm.
So, straight east. Fake Boeing 737. Interesting name. They're asking, will this launch be visible from Bermuda? It's going straight east. What do you think, Alex?
Not fully sure. I will try. Just look south. It'll probably be that way. By the way, I'm looking at the Starship pad right there. It's very tempting. No,
hey.
no, don't
hey.
pan left. Whoever is panning left. This is NASA's feed, by the way.
Yeah, it's a NASA camera, not ours.
They're panning left. Like,
yeah, don't
nope.
pan left. Don't pan left. Just like sneeze and accidentally rack zoom on or snap zoom on the Starship pad, and then pan left. Like that would be fine. Very interesting to see the progress happening at 39A for Starship. You can see the tower there on the right-hand side. We're not really focusing on that. We're focusing on IMAP. But if you want to know more about Starship's progress in Florida, we did do a flyover of the Space Coast in the last couple days, and we do have a Space Coast flyover coming out in the next couple days. Max,
later today should be.
Later today. That's right. It's Wednesday. What is time? Max, you were on that flight. A lot of really interesting things to see from the air out there at Kennedy and Cape Canaveral, huh?
Certainly lots. The orbital launch mount is making good progress over at Hangar X, and there's certainly a lot to talk about over at LC-39A, which is the very pad you are seeing on your screen now, albeit the actual launch pad in question is off to the left with the Starship facilities. But lots happening. There's always so much to talk about, and once Starship actually gets here, there's going to be a lot more even then. So this is just the I guess the what's the word? Oh goodness! It's also a band name. I'm blanking. Jack, help me. Genesis. This is the genesis of a Florida Starship you are seeing right now.
Yeah, there we go. Good band, by the way. I'm so glad you got it, because I was you're like floundering and like, throw me a life preserver, and I'm like,
eating Jack, help me!
I'm just
Jack,
eating a sandwich. Like, this is a pretty good sandwich. Everyday 001 with a $50 tip to tips.nasaspaceflight.com. That is outstanding. We appreciate every little bit of support that we get, even if it's not a monetary thing. If you're hitting the like button, telling your friends about us, sharing our feed and our channel with people, it all makes a huge difference. The super chats make a huge difference. But Everyday 001 went the extra mile and went to tips.nasaspaceflight.com and supported us in that way, which means it went directly to us. So thank you so much, Everyday. That is outstanding. Thank you. They said, thanks for a great answer to my question. Keep answering good questions. Keep asking good questions. We'll keep answering them. That's what we do here. We like to interact and we like to hang out and talk about space and learn and, rockets. Max, I think we should send you off so you can go do camera things.
It is indeed time to get ready. The solar disk of the sun is now just peeking out from behind the clouds, and it is time to dial in camera settings and make sure we have the right exposure. If all goes well, this is going to be a rather epic shot. So good luck, everybody. Hopefully y'all can enjoy it on the live stream, and we will see y'all on the other side.
Aim the controls for the heart of the sun, Max. That's a Pink Floyd lyric.
Kill the camera sensor. Okay, bye.
Yeah. Bye. Godspeed. We'll see you on the other side. ResistoJet's asking, will the probe remain continually orbiting the sun indefinitely, or will they have a plan
All
for
spacecraft
it?
are on internal power.
Nice.
Nice.
Once the primary mission is over.
I'm guessing that because it is true that the Lagrange points are roughly stable. There's actually a couple that are not super stable, but there's degrees of stability. Let's put it that way. L1 and L2 are sort of the most stable ones, but you still need some kind of little bit of maneuvering to be able
Right.
to control a little bit here and there because it's not a perfect. Nothing is perfect in orbital mechanics, right?
Right.
And so because of that, you need a bit of fuel here and there. At some point, they're going to be running out of fuel, right? And at that point, they're just going to be drifting away, and they're going to be orbiting the sun, not on L1 or anything like that. They're just going to be drifting away. Same deal will happen with James Webb, by the way. It's out there on L2, the other point. But it's got enough fuel for like 10, 15 years, so it's good.
I choose to believe by the time that that's even an issue, it'll be, ooh.
Wow.
I hope this shot works out. It's always tricky to line up a transit. You have to be in the exact right spot. The launch has to go at the exact right time. And, it's a tricky thing to nail. But Jerry is out there sending us this feed. That is really special. Thank you to Jerry for doing that. I am extremely excited for this shot.
It's also
Hopefully it works. I want to set expectations appropriately. Like, this is the sort of shot where you attempt it, and if it works out, awesome. And if it doesn't, hey, you sometimes you win, sometimes you lose. Like, it should work out. It might not. It might go right off to the side. It might go, not in the right spot. Of course, many things, a cloud could conspire against us. But if it works out, that's going to be really, really neat.
It's also really like these three missions are studying the sun again in different perspectives, right? One looking out, one looking sort of at interactions with the Earth, the other one looking directly at the sun. And so it's special as well if we can get that pulled off, right? So hopefully it works out because missions to study the sun and sun transit, right? It's like
how appropriate. How absolutely appropriate. Hopefully it works out. We have about 7 minutes to go. Also, I just really want to quickly point out that there has been a poll.
There we go.
There has been a poll in chat. It's 50-50. I'm flummoxed. Feel free to weigh in if you want to weigh in on that very important poll in chat. 6 minutes 45 to go. Bideford with a $25 super. Thank you so much, Bideford, for all of the support now, previously, and always. They're asking if it's too early for a jelly. It's too late for a jellyfish. The sun has risen too much. But as you just saw, we do have that experimental transit shot lined up.
Stage 1, RPM load complete.
We can see that golden hour light on Falcon 9. Fingers crossed, we get a launch here in about 6 minutes, and it'll be particularly beautiful. Alex, what do we have up next as we hit 6 minutes to go?
Well, next up should be in about a minute or so. They're going to be preparing for stromac retract. Tanks were pressurized for that. They're going to be opening the clamps at the top and retracting that stromac, that support structure next to the rocket, the white one, of course, not the black one on the right. And that's going to be retracting about 1.8 degrees away from Falcon 9 and getting ready for the final few minutes. We'll also see, we'll also hear, because now we have the comms net as well, the end of propellant load on the first and second stages, with the liquid oxygen load ending roughly T-minus 3 minutes in the countdown, and then T-minus 2 minutes for the second stage. T-minus 1 minute, we're going to have Falcon 9 entering startup when the ground computers will hand over control of the countdown to the onboard computers on Falcon 9 and getting ready for that final go for launch from the launch reactor, hopefully 45 seconds away from liftoff.
Thanks for pressing for strong back retract.
Right on time.
Nice.
I timed that answer with that call out, by the way.
You would. It's a very Alex thing to do. Good job. You did it flawlessly.
Next will be the one about, strong back retract.
Strong back retract has started. NLM, this is LD on countdown 1 with a status check.
LD, this is NLM. NASA's go for launch.
NASA's go for launch. Excellent. Under 4 minutes. I'm getting excited. Yep. We have that transit shot. Please let the transit shot work. This is a really fun mission, though. I'm excited that we're gonna get IMAP into space and be able to study the sun even more. And this is, as we talked about at the beginning of the stream, one of many solar probes that we have, and I imagine its science will complement like the science we're getting from Parker Solar Probe and things like that, right, Alex?
Yeah, it's gonna be part of the
Stage 1 launch load is complete.
There we go. Yeah, so for example, IMAP is the 5th mission under NASA's Solar Terrestrial Probes program, and so it's gonna be part of all of these different missions that are gonna be studying the sun, the interactions. Again, it's really important to know about this stuff because you never know when you're gonna need this kind of information, right? And being able to know about all of those things. Just imagine when there's like a coronal mass ejection hitting Earth and things like that. These kinds of payloads, not just IMAP, but for example, the NOAA satellite as well, that one is also going to study those. And it's really important just for awareness of what is going on out there. And there's many missions as well that are dependent on that. And as we move forward with human missions to the moon and Mars, it's going to be a rather big deal to know what the sun is doing and understanding how that impacts not just Earth, but also other planets.
Couldn't have said it better myself. I also couldn't have timed it better because now we are hearing that call out for Stage 2 LOX load complete, which means we'll see the 2-minute vent, the 20-minute vent's counterpart. Always blows my mind how quickly those 18 minutes go. As a blink of an eye, 20-minute vent to 2-minute vent. Here we are. More gas closeouts on the transporter erector. With 1 minute and 30 seconds to go.
Ground
Alex,
gas
what happens at a minute?
Well,
hear a call out.
Yeah, we're gonna hear it. So in 20 seconds or so, we're gonna get that call out of Falcon 9 is in startup. Falcon 9 will take over control of the countdown from the ground computers. The tanks will pressurize for flight. Everything will go into overdrive, if you will. All of the computers will be checking out everything automatically, making sure that all is ready for launch. Let's listen in.
Falcon 9 is in startup.
There we go.
Nice. Good work. Excellent timing. I love the shot of the press site and getting to see what each individual press person is doing at that moment.
The launch director is go for launch.
Someone getting a photo with a clock, someone setting up a camera. Launch director is go for launch. 40 seconds to go. Falcon 9 is full of propellant and frosty.
T-minus 30 seconds.
Looks like not a lot of wind this morning either. Hopefully we get some good audio. And hopefully that experimental transit shot works. 20 seconds.
T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff. Go Falcon, go IMAP, go Slippo L1, and go Corruptor.
Vehicle is pitching downrange.
M1D chamber pressure is nominal.
Oh, the transit! It worked! It looks like the transit worked! We're gonna have to look at that in the replays.
Falcon 9 power and telemetry are nominal.
Falcon 9 is supersonic. Max Q.
I'm back, chill.
Wow. It's still going. The audio is still going. I don't
It's
even want to
still
talk
crackling.
over it. I don't even want to talk over it.
Even as we approach main engine cutoff, it's still crackling.
That transit shot looked like it worked out. We do replays after launch. It's not replay time yet. It's still launch time, but I know we're going to go back and look at that
Still
again.
airborne.
I'm excited. I'm excited for that.
And shutdown of the first stage.
Oh my gosh, and I
Separation
just saw it.
confirmed.
Max is cooking in the back channel. Let's go.
And that's ignition of the MVAC engine.
Nice. First stage is like, see ya. Second stage is like, see ya.
Good second flight of that first stage. Now coming up should be fairing separation. Those two fairing halves are new, so this is their first time getting deployed.
It's a great tracking shot.
There's a
Fairing
shot.
separation confirmed.
Oh, they changed to the booster camera. There we go. Good job.
Really remarkable that we can see the RCS puffs from the booster in broad daylight. Gotta love the early morning launch. It's like a very faint, very, very, very faint jelly sort of deal. Second stage, continuing to pile on velocity. You can see that large vacuum nozzle wobbling.
This is still the ground track. Looking.
Yeah, this is a remarkable track considering that it's like going through clouds and it's two very dim specs.
Yep.
Really quite outstanding stuff. Really, Cape team,
Both
good job.
vehicles are following nominal trajectories.
Absolutely cooking this morning. Both vehicles following nominal trajectories. Hooray! T plus 4 minutes 30 seconds. First stage now beginning to descend. Second stage continuing to pile on velocity like it does. First stage landing on dirty, right? Right, Alex?
Yep, first stage is doing its thing. It's now coasting, and it'll be coming back down and land on just read the instructions. Now, programming note is that unlike on Starlink missions, the landing will happen after the second stage MVAC engine shuts down. So that engine on the right hand side will shut down first. The 3 satellites in that second stage will be entering a parking Earth orbit around the Earth, I guess. And then the first stage will be doing the landing. So that is sort of what we should see in around 3 minutes from now. Less than 3 minutes, actually. But first will be the entry burn on that first stage. Fighting fire with fire, I guess.
Fighting fire with fire. Supersonic retro propulsion. I mean, it's like one of my favorite things to say. Triethyl aluminum, triethyl borane. It's just a cool space-related word. And it was something that before Falcon 9, it was theoretical. It's like, man, maybe this is possible. Maybe we could do this.
And SpaceX just did it.
Yeah, they said hold my locks. No, like literally hold my locks. Like save a little bit of it for a supersonic retro propulsion test.
And yeah, the floating ring, by the way, that we saw, that was ice, and it's that shape because it accumulates in a very specific part that has that shape.
That shape.
Yeah.
It's ice. It's always ice.
Mm-hmm.
I got a text like 6 months ago from a very smart friend of mine, who knows I'm into space things. Here comes entry burn. And they were like, "Hey, is this a mouse?"
FTS is saved.
It's like, no, dude, it's ice. It's always ice.
It's always ice.
I would love for it to be aliens. It's not. It's ice. Three engines burning. They'll down select to the center one here in a moment and then end that entry burn. Turns out when you hit the thicker part of the atmosphere and you encounter that plasma heating, one way to stay colder than that is to enshroud yourself
Stage 2 is
with
in terminal guidance.
your own rocket exhaust. Absolutely beautiful views.
Stage 2, FTS is saved.
I feel like when they switched that other camera on stage 2, though, it's like breaking the 180. This is so film nerdy. Now we're good. This is good.
Transonic.
They broke the 180.
And there's the shutdown of the second stage engine. Wow, look at that
Nominal
booster.
park orbit.
Oh, I love the vapor going through the grid fins. Nominal parking orbit on the second stage. That's what we wanted to hear.
Wow.
First stage absolutely cooking down through some clouds. Gorgeous.
Landing burn. Wow.
Look
at that.
As it goes through a cumulonimbus cloud, look like. Grid fins doing the work.
Landing
Drone
leg
ship in
deploy.
view.
Landing leg deploy. God, they just make it look
Stage 1
easy.
landing confirmed.
And there we go.
They just make it look so easy, and it's just a miracle of modern engineering. Wow.
Look at those views.
Speaking of views, we do have replays coming up. We're working on replays. We're going to take a look at all of our different camera angles, including that solar transit. Speaking of, I know we have some photos also coming in from Max and the field. We're going to talk about all that. So don't go anywhere. Launch may have just happened, but we have a lot to go over, including some really awesome shots from the field. I'm excited. Oh, yep. Jerry's cooking. Max is cooking. Just stand by. We'll get those replays working, and we'll get some presentation action so we can show you some of these photos of this solar transit from the team. Excellent work. All right, so the first stage is back on the drone ship. Second stage in is parking orbit. You said it's going to be there for like an hour, Alex, and then and then it's going to yeet the payloads to L1.
Exactly. It's gonna do a relight of that IMAP engine. Should last for about a minute or so, that burn, and that'll be, as you said, yeeting the 3 spacecraft all the way to the Sun-Earth Lagrange point 1. Which they should get there around 108 days from now, so it's going to take a while. But in that time, they'll be able to check out the systems and whatnot. So it's kind of helpful as well, if you will, that they have a little bit of that time to do all of those checkouts of those 3 spacecraft. So, yep, very neat.
I just think they're neat.
I know that
I wonder,
reference.
there wasn't like any kind of or gray stripe or anything on the second stage? Or
Nope.
Was there, they didn't have to do anything particularly obvious to enable this longer coast?
Not really. I mean, a burn that long. There we go. That's the transit that we were mentioning.
Max got the transit. You can see the sun looks spiky. That's not like it. That is because of the acoustics of launch distorting the light. It's just wild. It's just a wild shot. Great work, Max. I believe Max did tweet this as well, so if you're not following Max, you should as well. Jerry got it too. We got the Jerry version, the Jerry edition. I like it. It's also so beautiful. Falcon 9 almost dead center in the middle of the disk of the sun. You can see the jelly from the heat distortion. You can see the acoustic distortion. I don't even know what to call it. It's just beautiful. Fantastic work. We are working on the video replays as well, so stand by for those. But we wanted to show you both of these tweets from Jerry and from Max. Follow Jerry, follow Max on all the socials. Whether you're on Instagram or, wherever. Twitter, Facebook. I think, do we have a TikTok? We have a TikTok, Blue Sky. We have a lot of things wherever you are.
Whatever is your favorite flavor of social media.
Exactly. Oh God, now I'm thinking about what the different flavors would be for the social media. I feel like
Twitter will be, or X, I guess, will be sea salt ice cream. Because it's very salty.
Sea salt and black licorice ice cream. Yeah. Instagram would be like cotton candy. Anyway, Mark, thank you for the super chat. No message there, nothing for me to riff on, just a super chat to support what we do. Mark Fetco Science, thanks, buddy. And Rusted Woods with a super chat as well. They say, thanks for great coverage. You're quite welcome. Again, we have those replays coming down the pipe. It's going to take just a minute, but stand by. I'm super excited to see that solar transit. Joshua Boley says, Max, make that a metal print. I'd be down. I think he'd be down. We'll have to talk to the store team. Katya is asking, is this mission mainly for the safety of the Artemis astronauts and further Mars expeditions? I mean, yes. It's also about safety of Earth orbiting satellites and people on Earth, right, Alex?
Yeah, I mean, the safety of Artemis astronauts and other Mars explorations and whatnot, it's sort of like a neat side effect, if you will. And this is why I always like when we've got these sort of very broad science missions where broad, whatever you know what I mean.
If you say broad, I think of bros. Like it's like something like bros did in the past. Like
Cut me some slack. I'm not a native speaker.
I'm just giving you a hard time. I'm so sorry. Why do you put up with me?
Heliopause a bit, Jack.
I helio can't.
Okay. But yeah, it's one of those things. You sometimes doing certain science, you never know what the sort of side effects of knowing that kind of science will benefit the future, right? And this is one of those things where it's like, yeah, it's neat to know more about the sun and about how it interacts with the interstellar medium, right? Which is what IMAP is all about. Then you've got the geocorona satellite as well, where you look back at Earth and all of that interaction with the Earth's exosphere, that outer layer, the last layer of the Earth's atmosphere, that final contact with the interplanetary
I'll
space,
be
right?
stepping off for 10.
Okay.
What? That's an interesting call.
And then you've got the other one looking at the sun directly and being able to look at coronal mass ejections and whatnot. And that one in particular helps us here on Earth. But again, it's those side effects, those good benefits that you really don't think about it in the moment, if you will, but later down the line it may help, right? And these are sort of the side quests, if you will, of science in space and the kind of things. I mean, you can point at 1,000 or hundreds of thousands of different applications in space that have benefited multiple different things just by applying them differently, like GPS, lasers, and whatnot. Like there's thousands of different things out there.
Well, and it's also sometimes you do a mission or you do science with a specific goal in mind. Sometimes you don't know what you don't know, and you learn things along the way that you didn't expect. It's just good to learn more about our place in the solar system and the Milky Way and the universe.
Yeah. I could probably go on and on because I studied physics and I'm the kind of person that will be very annoying talking about how fundamental science is to things that in principle at the beginning of doing that kind of fundamental questions about nature of matter and whatever, right? You will be like, why do I
nature
care?
of matter, Alex?
Yeah, why would I
is
care
matter?
about electrons and protons or whatever, right? Like who will care about that kind of stuff? But then you can apply those things to different technologies and different applications,
right?
In many different fields, and and you never know when that might apply. And again, it happens with so many different research, and I could go on and on.
Oh yeah, me too. I know all about this stuff, like neutrons, protons. I hope you're staying glue on to your stream here because we do have those replays coming up. I hope you're excited for the replays. I'm excited for the replays. Alex, did you like what I did there?
Yeah, I mean, you want to know another thing that I'm really excited about, and it is not even in the near future, because IMAP is going to be looking at the interaction between the interstellar medium and our own heliosphere, that sort of magnetic field around the sun. At some point in the future, man, we're gonna have proper interstellar missions. We need to know about the interstellar mission. The interstellar medium, right? We may go to other stars in the future. Wouldn't it be great to already start learning about that kind of stuff now instead of leaving it for later? I'm really excited about that sort of stuff.
Yeah, I mean this will inform us in terms of the interaction between the Earth and the Sun. It'll also inform us between the interaction of other stars and planets in their solar system, which is valuable information. Maybe not anything in the next...
Even in our lifetimes.
Yeah, but still...
Or the next century, but at some point in the future, it's going to happen, right?
Right. Like, absolutely the sort of thing that you should start on at some point. It's like, do we want to figure out how to redirect an asteroid now? Well, we don't need to.
Yeah.
Well, let's go smack dart into an asteroid and do some science and figure it out now so that when we need to know later, we already know.
The other one as well, the Carruthers Geocoronal Observatory, about the interaction with the exosphere. That's going to be amazing if at some point we do Mars terraforming, because the sun, the solar wind, right, blowing away the
Right.
atmosphere. We want to,
Kind of
not have
important.
that.
Yeah, that's a really good point.
Replays.
All right. All right. Well, I was going to ask you to heliopause again so we could look at the replays. Let's go. This will be from Fleet Cam over in the port. It'll be more of a wide shot, more of what you would see with your own two eyes. You can see Falcon 9 rising into the sky there, just near the boom of that crane. Jib? Boom? I don't know. I'm not a cranologist.
I like the cut of your jib. Something like that. I
You
don't
tried
know.
to stop yourself. I love that you. I love that you tried and couldn't. Oh, we got bars and tone. Sorry. That's my best 1 kilohertz tone.
Falcon 9 cooking it there. That will be what you will see if you go to port, by the way.
Yeah, this is, like I said, pretty close to what your eyes would see unaided, which is neat.
Yeah, because we always, we of course zoom in and have these photo lenses. Excuse me, my God, my brain today it's not braining. But yeah, we always zoom in and whatnot, so you can see the rocket as we track it up into space and whatnot. But that view is pretty much what you will see with your own eyes. I think this one too. Like it's not even zoomed in, and so yeah.
Yeah, and there's some restaurants there in Port Canaveral, and one of our cameras is hosted at Rusty's, where you can go and see basically that exact view. Here's a shot from one of our KSC cams. I like how it slowly zooms in and then tilts up. Very, very nice shot. I'm not sure who was operating that camera. It might have been Gage. I suspect this one might have been Gage. Oh, it's a NASA cam. Haha.
And zooming in as it tracks uphill.
Right. See, it's one thing to nail a move, whether it's a NASA or whether it's a rocket track or whether it's like you're tracking a car or it's whether it's a drone shot. It's one thing to nail a move in one axis, but when you have multiple control inputs, when you're zooming and tilting and tracking, that is that's peak. That's the hard stuff. It's another shot from the press site area. Zooming out, interesting choice.
That I think it's not from the press site.
And
looks from the north.
Okay, my bad. Beautiful golden hour lighting on the rocket.
Causeway, yeah. Okay.
Causeway, thank you. Absolutely gorgeous.
It's also really interesting the contrast between the blue of the sky behind Falcon 9. And I think it also had a vapor cone on this one.
Yeah. You love to see it. Just so wild to me that it's a giant point source of light. And you can see how it, like when there's a little bit of clouds, you can see the light just sort of splash around on its surroundings as it ascends through them. It's just beautiful. Another shot of liftoff. It's from one of the berms at 39A. Just gorgeous. Nice. Here's one of the pad cams.
I always love this camera because it gets blasted.
Right. Get to breed, idiot. Or get
I'm guessing. I'm guessing this
Payload-
one. Yeah,
Payload
go ahead.
processing facility. PPF.
Exactly. Yeah, SpaceX's own payload processing facility, about a mile south of Space Launch Complex 40.
Love that shot. Locked off, didn't tilt up, just let the rocket ascend out of frame. And there's that moment where it just looks slow. I love that one, brief moment in liftoff where it's cleared the tower, but it's still not really cooking yet, and you're like, is it going? It's going. It's going. It's going. That's probably my favorite moment. Hey, look at the sky. It's orange.
It is.
Beautiful. Yay, replays. We do have the solar transit replay coming. I think that one's going to be last. So I hope you're all as excited and hyped for it as I am. I have not seen it yet. Nice wide shot showing the morning lighting at the press site. You got the flag. You got the clock. You can't go wrong. Whee!
Oh, that's from Cape Cam, right?
Nice.
Gavin tracking.
Nice. Love that, like, ghostly plume.
You can see how quickly it goes in the sky.
Yeah.
There we go.
It's hauling the mail. Light the engines, light the engines, light the engine. It's like, after Miko. Chat, are you excited for the transit? Because here it is. Wow.
There we go.
Excellent. Look at that.
All the turbulence there.
Yeah, all the heat distortion on the disc. Just gorgeous. Do it again.
It's also really interesting how the exhaust plume.
Jay, can we clear the ticker?
You can see the Mac diamonds.
You can. Wow.
Like a sort of mega Mac diamond of sorts from Falcon 9.
No kidding. This sort of thing that, like, this happens, this heat exhaust sort of distortion, it's there. We just get to visualize it because of these conditions. Really cool shot from Jerry. Max and Jerry both absolutely cooking this morning. Really cool. I'll keep playing it. Just keep playing it. I just want to keep watching it. You can even see, the whole entire, like, if you look at the right side of the sun as the rocket goes through it, right there. See how the whole entire right side wobbles and, like, becomes soft briefly? That's that acoustic distortion.
I like the fact that you can see the sunspots before the transit, and then whoop, get transited.
Get transited, idiot. You stupid fusion ball. Nice. Ooh, I like the slowed down version. Very cool. This is the sort of thing we can only do with the support from everybody out there, so thank you so much. This is just such a treat to be able to pull off. Ooh, even more slowed. It's like when you
just do it frame by frame.
It's like when you see a song on social media that's like, song number 7 super slowed with reverb.
Can we stop it there?
Can we add reverb?
A little bit earlier, when it's right with the exhaust right across, a little bit in between. Hang on.
Wow.
We're doing backseat producing.
Yeah,
Well,
you're
I
bad.
am.
You're being not good.
Few frames after.
Oh my God, Alex.
There we go. Okay, so you can see the complete plume now. You can see sort of where the plume goes in and then out and then in again.
Yep.
Those mega Mach diamonds of sorts. Because
It's
we
not
see
mega.
those.
It's not mega.
It's mega because it's all 9 engines, though.
It's not mega.
It's not the individual engine Mach diamonds. And so it's sort of the same effect that we see with Starship and the 33 Raptor engines on Super Heavy, where the combined thrust of all of them and the pressures and whatnot add up to a much bigger Mach diamond. Super cool.
All right, it's kind of mega.
It's mega because it's like a combination
It's
of
a medium.
all the little
it's
ones.
a medium Mach diamond.
Medium.
I mean, Falcon 9's a medium lift launcher. Maybe. Am I getting away with this? No? All right. Hey, it's our favorite view on launch day. An empty launch site, and also a Starship pad that's getting built. Except it's not our favorite view on launch day. My favorite view is that transit. Can we just watch the transit a couple more times, Jay? I don't want to. Go ahead.
I was gonna make the joke. There's an empty launch pad, and also the Falcon 9 transport reactor is going up.
Yeah, yeah. There's an empty launch pad, and also there's also another empty launch pad.
Soon. Oh, I cannot wait until we see Starship.
Yeah, Starship from 39A is gonna go so hard. It's gonna be amazing. It's gonna be absolutely amazing, and it's not that far off. We teased it a little bit earlier in the stream. We do have a Cape flyover coming up, so I think that's later today. We'll be posting that Max and company on the East Coast did a flyover, and we got to see a whole bunch of the different Starship developments happening at the Cape. So if you want to be apprised of all of that, that's a good way. So stay tuned. I know it's like the stupid YouTube cliche, like hit the bell. I mean, we don't post things. We don't go live unless we think it's worth your time. So consider hitting that, turning it on, doing the thing. Because we do have a whole bunch of awesome videos coming. I mean, we just did a flyover of Starbase too. Yesterday, what is time? Monday's video, our Starbase update this week, also featured flyover footage, not only of the Cape, but also of Starbase. So just constantly trying to bring you guys the best coverage we can of all of the developments happening. Mark Fetco Science, thanks again. They say a Cosmic Dance, new video out now. Interesting. $50 super, thank you so much. Shazbert Toddbot, $10 super, thank you. They say that was an awesome sun transit shot. Watching from the start of my work shift in Nolens. I think that's how you're supposed to say it. Mark, again, thank you. And Matthew Oda becoming a PadRat member. Nice. Mr. Fluffy asking if I'm going to KSC for New Glenn, if NG2 ever happens. Depends on when it is. I really do need to get back to the Cape. And I really do need to shoot a Vulcan and a New Glenn, among other rockets. So
if it happens in November, there's a chance that you'd be a little bit more free, because no Starship launches for a while.
Right, and I'm gonna say this out loud on stream on the off chance that my parents are not watching, but I did just get my Land Rover fully up and running again. In theory, if Starship wasn't occupying all my time, I could just drive to Tampa and surprise my parents and then shoot a launch. Like, that would be pretty cool, right? I hope I didn't just blow the surprise. Nobody tell my parents.
Are you going to be on Artemis too?
Oh, 100%. 10,000%. I would never, ever miss an SLS.
What if Flight 12 happens in February, though?
Oh, God. Alex, why do you want to hurt me? I don't know, man. It depends. I mean, I am a team player, so it's whatever we need in terms of coverage. That is my, that is step 1 in the flow chart. Step 2 is, yeah, I mean, it would be we're talking about the first Block 3 Starship. That would be outstanding and certainly notable to catch, but there's only going to be so many SLSs. There's going to be many Block 3 Starship launches. There's only going to be a handful of SLS missions and launches. Man, Alex, why you gotta do that? Ooh, are we ready to show it? Are we ready to show the thing? Can we show the thing? Do we have the thing? Can we show the thing? Jay?
Show the thing.
Show the thing. Do the thing. Can we do the thing? Jay hates me so much right now. It's the transit shot again. Well, it's the stream transit shot again, which is amazing. However, oh, psych! We also have a print in the shop. Hooray! I think this one is from Max, if I'm not mistaken. I'm looking in the back channel for someone to correct me. But yes, for those of you that asked for the print, it is from Max. Excellent. For those that wanted the print in the shop, we heard your cries. We saw them in chat. And now it is available both on metal and on paper. Whatever you prefer. The metal prints are printed directly on metal. They don't need a frame or anything. They're super easy to hang. And ignore the fact that the money is in pounds. Don't worry about that. But for real, it really does make a difference. Every little bit of support both helps NSF. You get something cool in return. And in the case of the metal prints, a portion of the sale goes to the photographer who shot the image, allowing them to level up their equipment, repair equipment, and, just like live, like pay for gas and food. So yeah, metal prints exist. Paper prints also exist if you didn't know. If you're more into that or more on a budget, or you just want more of a poster vibe. But there's all kinds of metal prints in the shop, not just this shot, but this shot is now live in the shop. If you want to check it out, we would be honored for you to even consider putting our work on your walls and decorating your space with some of our spaceflight art. We gather these photons diligently, carefully, painstakingly. We put the photons in the exact right order, and we color the photons, and we talk to them. We tuck them in at night and say, go to sleep, little photons. Have a good nighttime nap. We really care. We care about the prints. We take a lot of effort to make sure the prints are good and that you get a good product. So thank you for even considering it. I'm surprised I got no pushback. I got no pushback on that from you at all, Alex? About the photons? All right.
It's okay. It's okay. I mean,
Mick Ronald in chat says Jack is losing it. Petrie says he's lost it. Yeah, Petrie. Well, my name isn't Petrie, at least. What's up with that?
As long as you don't heliopause the photons, we're okay.
As soon as I did it, I felt kind of bad, and then I saw your message in the back channel, and I was like, "Oh, now I feel really bad." I did just interrupt you for a terrible joke, but I guess that's kind of par for the course.
I guess you could call those helio images, helioprints. I don't know, whatever. It's literally an image, right, of the sun. So the helio prefix,
Heliograph,
suffix, whatever. It's
heliography. Anyway, what a treat. What a fun launch this morning. I see Jerry's still in CommsNet. I'm not sure where'd Max go? Jerry, can I yell at you? Hi, Jerry, are you
Max
there?
abandoned us.
Max is an abandoner.
Yeah, totally.
Jerry, we're going to wrap. I'm going to do outros. If you're there and you want to unmute and say hi and have your adoring fans hear your voice because you did great with the solar transit, feel free. If not, thank you to Jerry, who was out in the field, for grabbing that solar transit for us. And also, thank you to Max, also out in the field, grabbing those awesome shots as well, as you just saw in the shop. Florida team absolutely out in force this morning, nailing that transit. What a treat. You can see their info popping up in the top right there. Again, if you don't follow Jerry, if you don't follow Max, you probably should. I don't know really what you're doing. They both are legends, so do that. Speaking of legends, we also had Alex on comms. Alex, you're a legend.
Yeah. It's okay, I guess.
You know what we didn't do on this stream? We didn't do a this time of year localized entirely in your kitchen. We should have figured out a way to work the Aurora Borealis bit in somehow. Maybe next time. Maybe next time there's a solar science mission.
Yeah. Let's see when's the next one.
Yeah, right. Also, we had Jay operating the stream. Thank you to Jay for that. I'm Jack Beyer for NSF. Thank you so much for watching. Thank you all so much for all of the support.
More streams tomorrow.
We could not do what we do without all of you. Yeah, more streams tomorrow, more streams all week. We were not going to stop. We had Carson operating as well. Thank you to Carson. And we had, I think, Gage working some cameras in the background as well. Yay! Yay, team! All right. With that, we'll see y'all later. You can hang out at Space Coast Live or Starbase Live or McGregor Live, but you can't stay here. But do go hang out at one of those. And watch the Space Coast update. Like, do that.
Yeah, later today.
Yeah, later today. Watch the Space Coast update. Do it. All right, bye!
And here we go. We have liftoff.
Propulsion continues to be nominal.
RS-68 chamber pressure looks good.
Following up. Roger, planet.
Water towers, fly! Yes! Tango down to nominal.
Flight outside of speed off. Say again, SPD off. It's orange!
R45! Oh my god! Oh my god!
Decollage.
Look at this!
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You good? Sure. We don't need any more of these.